the Schrader core. This little guy right here gives us the convenience of checking highly pressurized systems with just the twist of a finger. Come on over. Let's sit down. Let's get comfortable. Let's have a little talk about this. The Schrader core, or core valve, or just Schrader sometimes, was first invented back in the late 1800s by a man named August Schrader. So there you have it. That's why we still call it a Schrader. This guy gave us all the convenience of checking our first bicycle tires, then car tires, and then systems that hold pressure like HVAC, conveniently checking them, charging, servicing, by just pressing in this tiny valve. This little valve is going to play a key role in your HVAC career. Hear that? A key role. So my job today is try to give you as many tips and precautions and advice, whatever I got for you from my 10 years of residential HVAC, on how to use these bad boys in a way that makes sense and won't get you hurt. Got it? Let's dive in. First off, let's talk about safety. You guys have seen the videos and pictures, or maybe experienced it for yourself. Pretty much every technician has. They go to hook up, so they get their hose and they go to hook up to a system, and what happens? They go to hook up to a system and suddenly refrigerant starts spraying out. There's a bit of panic, there's a bit of meltdown. They grab it, they try to fix the problems going on. The refrigerant starts spraying on their hands. Liquid refrigerant is freezing off instantly as it hits the air outside. After all, if this is 410A, which is what it got in this system, you know, 0 PSI is minus 60 degrees that this thing's boiling at. So yeah, that'll instantly burn you, and you've seen the pictures of the welts on hands and stuff like that. So first thing I'm going to talk about is safety, how to avoid getting hurt, what are the proper tools to use, and how we can get that done. First of all, here's just a hose without any valve or any other connection. And on this hose, you have the core depressor down here in the middle. Its job is, as its hose is threaded in, it's going to push the back of our core. It's going to push the back of this core right here in. And as it does, you can see that we're pushing against the spring of the Schrader valve, and the valve opens up, and refrigerant can seep through there and then out the top of the valve here. And so as this screws in, we have this metal piece in the middle that depresses the valve core on our hose. I think we've all seen or witnessed ourselves hooking a hose up backwards. On the back side of our hose, we have no core depressor. There's no little metal valve on the middle of that. So if I were to take this hose and screw it into this system that's fully charged, here we go. I might get sprayed a little bit. Nothing's gonna happen, right? There's no depressor on the back of this hose. There's nothing back here to actually push in the pin of our Schrader valve. So that's the first lesson. You actually need your hose that you're going to be hooking up to the system to have the core depressor in it, and it actually has to engage that. Now this hose has no valve, no ball valve, no safety on there. We don't have a low loss fitting. We don't have a core depressor attachment. So technically, according to the EPA, this hose is not allowed. We aren't allowed to just take this and hook up to a pressurized system. There has to be some sort of low loss or blowback protection, so that when we remove our gauges, the refrigerant that's trapped in a hose doesn't dump anywhere. Let's talk about that first. When I hook up a hose, I'm going to go ahead and do that now. I'm going to go ahead and hook up this hose. When I hook up a hose, the pressure has gone and filled the hose all the way back and is now pushing against this gauge. So this whole hose is filled with refrigerant. If I go to take off this hose, A lot of what you experience when you take off a hose like this that's spraying out and maybe getting on your hands is just what's trapped in this hose, the refrigerants that's trapped in this hose. And so a ball valve like this on the end of this hose, like this NAVAC hose has a nice ball valve on the end, I can shut it off, remove my hose, and the only bit that I may lose is just taking these threads on and off from here, but now my refrigerant is held in the hose. So I'm not spraying all over the place and risk burning myself. Now, in order to save the refrigerant in your hoses, you do want to, while the system's running, close off your high side and pump back through the hoses and release your high pressure and your liquid back into the system, but that's not what today's video is about. So first line of protection, one of my favorites to use is actually just a ball valve on the end of my hose. You can turn that off, and that's the same as your low loss, your blowback. As far as functionality, it's the same. You can control it, you can open it and close it. Second, and probably the most popular for the new guy, is this blowback fitting. So inside of here is a safety that when the core is not depressed, the spring pushes the valve internal to here closed. It's almost like a Schrader within a Schrader. And then that seals the hose that's hooked up on the back side of this and holds pressure. Now, it's less convenient in my opinion because you don't have the ball valve. The ball valve on here, you can actually close down and open up when you need to, whereas this one, it's just stuck in there. Some issues with this that I've noticed, and it's important to know this, is that these will sometimes get stuck as you go to tighten them in. A little bit of refrigerant will fish through and then it'll reset and seal again. So if you don't actually have it all the way engaged, you can get a false reading. You can get a reading, a PSI reading that's actually 20, 40, or 60 PSI below actual system pressures. And it's because you started to engage the Schrader and then it reset and sealed and you didn't actually push this in all the way. So I've noticed many, many times that newer techs that use the blowback fittings, the low loss, do actually get hung up sometimes when either they start to fail and catch, or they haven't engaged it all the way. They haven't actually pushed it in all the way and engaged the release valve on the inside of this, and so they're reading the wrong PSI. Good to know. Keep that in mind. Now, the absolute safest way to check a system and not get sprayed on the hands, not actually get covered in refrigerant, is this tool right here. Some version of this, I like this one right here, but it has a core, it's a core depressor. It has a core depressor on there that's threaded. And so you can actually unscrew, can you see that centerpiece on the camera? You can actually unscrew that and it pulls out. Now most of these they don't have a Schrader core on the inside of here. It's not needed. But when this is unscrewed all the way, I can't blow through. There's no pressure getting between here and there, so it actually seals. It sits in there and seals flow from here to here. That's one thing I love about this one, this valve in particular. Then I can take it and I can screw it onto my system. And with the Schrader core depressor pulled out, I'm not actually engaging the refrigerant. Then I can take my hoses and connect to the system like this, and we don't have any blowback, any danger of getting sprayed with refrigerant, any worry that our hands are going to be bothered at all by this. When I'm ready, simply screw in the core depressor, and as it goes in, it engages the core, and you can see the pressure go up on your gauges. You know that this has done its job. So this can help you if you want absolutely zero hiss, you don't want any blowback, you don't want any spray. Having a core depressor is the absolute safest way to engage with your Schrader cores. It is important to know how they work. Sit there and pay attention to what you're doing. If your core depressor has not been unscrewed and you go to put it onto the system, you're going to spray everywhere. So let me give you an example of that. If you're not paying attention and your core depressor is engaged. So this has been screwed in, and it actually can engage the core. And then you go to put it onto your system, the refrigerant's going to immediately begin to spray out of the top of this, which is typically aimed up at your face. Next thing, a real practical piece of advice when hooking up. Your low pressure side, your vapor side, is typically you're going to have some spray, but there's usually not liquid on the vapor side, especially if the system's running. So you don't typically get burned from there, but you don't want to lose refrigerant. So use something that you can hook up to that's not going to leak a bunch of refrigerant. Your high pressure side, not only is it high pressure, it's also liquid that you're hooking up to on the liquid line. And so that is where you run the risk of getting burnt the most. That liquid boils off and freezes and burns you. You have to be very careful. A couple tricks. If the unit's running, your low pressure side will be lower pressure. It's easier to hook up and unhook on a running system on the low side. However, if your unit's running, you're going to have a much higher pressure on your liquid side. So you run more risk with a little bit higher pressure liquid on that valve. So just keep those in mind. Something that I notice a lot of new guys do when they go to hook up their hoses, and I'll just use this out here so you can see a good example of it. Let me take the low loss off, and I'll show you right here. So when you go to hook up, a lot of guys will come grabbing the back of the valve like this, and they'll screw it in like this. Now the issue with that is as it starts to engage the Schrader, it's going to leak right off the back here and out the front of the threads. And so if your hands are back here or anywhere, that's the primary place that it's going to leak onto. So what you want to do is I'll usually set it and get 1 or 2 threads on, and I'll rotate my fingers to this position right here. If there's refrigerant spraying out of the front and back, I'm not going to get hit. It can spray all that it wants without me being worried about injury. I can continue to tighten this down until I engage the fittings, the gasket, and the seal, and so it stops spraying. Same thing when I'm taking it off, I'm going to very carefully position on the middle of my hose to make sure that when it sprays off of both ends, it's not hitting me. So pay attention to where the rest of your hand is when you're taking a hose on and off. That's one of the best tips that I can give you as a new technician. All right, next I wanted to talk about actually the care, maintaining your hoses, and another thing that makes connecting and disconnecting safer and much more convenient. The position of your Schrader depressor inside your hose is crucial to how well this all goes. If you have a core depressor that is sunk in too far, then on some systems you're going to have a hard time actually engaging a Schrader. Some of the systems, the Schrader is going to be, let me pull this out so I have a Schrader I can point to. On some systems, the Schrader is going to be a little bit deeper, one design to the next, and you could have a very hard time actually engaging it if your core depressor is too in. But much worse than having your core depressor all the way in is having it too far out. This core depressor is adjustable. You can take it and pull it out. I usually twist it a little bit and put some tension on it to work it in and out. So if you can see there with your camera angle, I have pulled it out and it's now above the black seal. Because it's so far out and it's above the gasket, when I go to press in this Schrader, it's going to engage the Schrader before it actually makes a seal against the valve. And so we're going to spray like crazy as I'm trying to tighten this thing down. If I simply take it and I press it in, you work that back in. Some of them are threaded where you can actually screw them in and out, but a lot of them, I'll pull it out for a second and show you, you just push it in and out. So now I've pushed it all the way back in. And what's going to happen here is that when I go to tighten this down, the gasket will seal against the valve before the Schrader depresses. And so then we're not going to have a bunch of spray. In order for this to work properly, you need a good clean gasket that's at the right depth, and you need your core depressor at its right depth. Don't be afraid to make adjustments on this, even system to system. as you show up and you look at it, if the core is a little further in, you might have to pull it out a little bit. But most importantly, keep these seals brand new, and you're going to save yourself a lot of heartache and the risk of being injured. Let me go ahead and pull this core out for you. Okay, well, this gasket came out with the core, which is great. That's convenient for me. All right, so this one's threaded, which is very convenient. You can just twist it in and out. And then some of them are just notched with an angle, and the name of that is escaping me, and they pull in and out. The threaded ones are a little bit easier to work with, so it's nice that Navac has the threaded ones in their hoses. You can just unscrew it and screw it back in at the depth you need. Here's a good looking seal, and it's brand new. It's actually, the Navac hoses all come with replacement seals in the packaging. So as they start to wear out, you have a couple more that you can put in there. And then buy extra, keep them on you. They'll make your life so much easier. Let me open up and show you a hose that has seen some use. So here's a hose, a gasket that is all torn up, and it's seen quite a bit of use. Let me get it pulled out. And this is the one that's not threaded. It just has the ridges, and so you just push it in and out. And let me get that gasket out. So once that gasket has, I'm not sure how well you can see that in the camera, but it's all torn up and it's been depressed. Once it's all torn up, it sits down below the ridge of this. And so then you're not making the seal against the tip before the Schrader pin is actually depressing in the Schrader. So that's crucial. Keep your gaskets replaced on a regular basis and clean. And it really is just that easy. You have these tools by you, you have the gaskets in your tool bag, keep them right there handy. Push the gasket in, and again, this one, the Navac one, is just a thread in, which is super convenient. We just thread that in. Most of the time you're going to go as deep as you can and adjust out as needed if you're not making clean contact with the Schrader. So there's a couple tips that will help you a lot. The last thing I wanted to talk about, so that was safety, how to engage in a convenient way. Another thing that I want to talk to you about is replacing them. These little bad boys can be a major pain when they start leaking. It's a really tiny valve stem. This metal is so small, so it can warp, it can bend, it cannot seat properly. You can get bits of sand or dirt clogged in there, and then it no longer seals on its own. It starts to leak. And in that case, you have a constant leak coming out of your system here. And if you have a good valve and cap on there, you can hold back some of that. But if the leak's bad enough, it'll leak through your valve and cap. I do want to say this. These are the most common misdiagnosed leaks in the industry, and it's not misdiagnosed. A technician can't find a leak on the system and they blame the Schrader valve. And so I just want to say, stop it. Don't do that. Let's just be technicians. If it's leaking, find the leak. Don't blame the valve. If it's in the valve, put bubbles on it, get some proof. Trust me, that senior technician at your company is going to want to see proof that it was actually leaking at the Schrader valve, and that wasn't your excuse. All right, rant's over. If you pull up to a system and it has been leaking from the valve, usually the inside of your cap is going to be filled with oil. So there's a tip. One cap filled with oil, the other cap dry, you might have actually had a leaking Schrader. Okay, we can't talk about valve cores without talking about the valve core removal tool. So the valve core removal tool is actually designed to be able to take a valve out while a system's under pressure without losing any refrigerant. And so let me just show you real quick how that's done. So you have your valve core removal tool, and it has no Schrader depressor in here. So I can take this onto the system, screw it on until I got a seal. Then I'll take the tool here, and then back here is the threaded seal on the back side of the valve. Screw that in place, Now this is what you can do if you actually have a leaking valve like we talked about before. If you actually have a leaking valve, you can use this to remove the valve and replace it. I'm going to press this in until I engage the valve, and you can twist it with your fingers and you'll feel the back side of that tool as it's spinning eventually lock in and connect to the back of that valve. Then I'm going to need to apply pressure while I unscrew that. So the pressure of the system is going to push against this valve. As soon as I unscrew it enough that it starts dumping refrigerant, it's going to try to force this valve open. So with one hand I'm pressing in, and with the other hand I'm unscrewing it as I go to remove this valve. I shut off the ball valve, so now I can pull this out without losing pressure. And there I have the valve removed from my unit. If I open this ball valve, all of the system's pressure would just dump out of here unhindered. It's normally being held back by this little tiny core right here. So if this thing is leaking, I got an issue with it, I can replace it with a new one and put it right back into my system. Now, not every time does this actually happen smoothly. Sometimes you go to take them out and they catch, or they're stripped, or they break in the process. This is a small piece of metal. They break in the process inside of here, and then you're stuck having to either pump down or recover refrigerant from this system to get that valve out of there. This allows you the chance to do it without having to do that whole procedure, but sometimes it doesn't work. And if you try a few times and you can't get that valve out, you're going to need to leave everything here in place, pump down your system, recover the charge, whatever it is, and then take that valve core out. All right, so now I'm pushing against probably around 260 psi, given today's temperature, as I push this valve back in place. It doesn't take much. As you feel it start to catch, it's finger tight. You don't need to crank on that. Again, it's a small piece of metal, small threads. You can easily over tighten the valve core. Let's take the back of this off. Safety first says that I shut the ball valve, take the back off. I cautiously open it and make sure that I'm not dumping refrigerant, and then I can remove the whole valve. So that's how you use the valve core removal tool. Now, other than a leaking Schrader core, we actually use these valve tools much more commonly when we're doing recovery or pulling a vacuum. And why is that? Well, the reason is this. Let's grab one of these bad boys, take another look at it real closely. When you recover or you pull a vacuum, you want as little resistance to the flow of refrigerant as possible. A valve core creates actually quite a bit of resistance. It's a very small point that refrigerant has to get through. So if I take my valve core and I depress it, and you can see it opening there, there's a very tiny pinhole at the base of that. I'm not sure how well you can see that. There's a very tiny hole at the bottom of your pinhole that all of your refrigerant actually has to fit through. Whereas if you take that valve core out, then you now have a huge open flow valve that your refrigerant can just flow straight through. So if you're looking at like points of resistance, like right here I have the Navac Big Boy evacuation hose. And we all know that when you have a giant hose like this for evacuation, it speeds up your process significantly. The larger the hose, the less resistance to flow. And so the same thing for your valve core. You pull it out. I'm just going to put this on the edge of the hose just for reference. You pull it out, so you're creating as small amount of resistance to the flow of refrigerant as possible. So it's important to take your valve cores out, recovering and vacuum, and you'll speed up the process significantly. Quick recap. If you don't take how you interact with core seriously, you can injure yourself pretty badly. We've had many people have to go to the emergency room in the last 10 years who didn't follow procedure properly and they got burned. Something I wanted to say about safety is the type of gloves you use. if your gloves don't have a rubber protection, if they're not waterproof, they're probably not the best gloves for this. If you have a major event where you're leaking refrigerant out of this, just any glove is not going to work. If you put a glove in there that can soak in the refrigerant, that can get wet in that and then immediately start freezing, or your sweaty hand has made the glove wet and it freezes, now you have a glove frozen to your skin. You go to rip it off and it can be pretty awful. So find a glove for interacting with refrigerant that has a rubber waterproof seal on the tip of the glove, and that'll be important. But more important than gloves, more important than safety glasses, is that you find the right safety equipment. Have something like a ball valve that you can shut off. That's going to be crucial. A blowback valve. They aren't quite as reliable. You have to get to know them, but they work. They will protect you. Or the absolute safest thing is actually the core depressor. A core depressor is always in my toolbox. I have it on my probes when I use probes, or my hoses. I usually actually just leave it on the hose. And if I have a hose without a ball valve, I can just leave it on there, and the core depressor will push that in and out. You have full control with the core depressor. There's no spray, there's no nothing. So using the right tools is going to be the first thing that keeps you safe. Having the right gloves is important. Last thing I want to say, if you don't hear anything else, hear this. If you're having a problem, it's gushing refrigerant, don't reach in there in a panic and try to fix it. This is where people get burned badly. It starts spraying, refrigerant's going everywhere, and they say, oh crap, I need to fix this before somebody sees, before my coworker notices, before the homeowner freaks out, whatever it is. We can pay for refrigerant, but you can't pay for new hands and fingers. And you can't pay for that time off because you hurt yourself. Like whatever it is. It's important that you take the safety over fixing what's going on with your system. But it's easy to have a panic, and you see it spraying all over the place. So what I would say is this: if it starts spraying, going crazy, walk away from it. Understand that it's more important to keep yourself safe. Now there are times that I've taken the hose off and the core inside just started spraying like crazy. It wasn't sitting right at all. And I've been able to fix it before with gloves and a valve core. You have the valve core open when you slide on. That way it's not building up any pressure. And you're carefully threading in so it's not actually spraying you or on your hands. It's still spraying out the back. And once it's sealed, you can shut it. Now where this goes wrong is people panic, they try to figure out something fast. It starts spraying, stop, take a breath, settle yourself, look at it, see if there's something that can be done immediately to fix the problem. And if not, let the refrigerant spill out, and you'll have to recharge that system and take care of the problem afterwards. So there's your Schrader history and practical help, use, safety from Bert. I hope that was useful. I hope I save a few of you guys from getting burnt and take away some of the fear of interacting with the system.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community, for techs, by techs.